Good morning to all. I am Niveta. We are going to see a 8086 pin diagram. 8086 is a 16-bit microprocessor. So it has a 16 data lines and 20 address lines. Address lines and data lines are multiplexed. It has a two modes. One is a minimum mode and next one is a maximum mode. The multiplexed address and data bus act as a address bus during the first part of machine cycle, that means T1, and data bus form the remaining part of the machine cycle. So and the address and status bus are multiplexed during this T1 or the most significant address lines for memory operations. During IO operation, these lines are low, that means low signal, zero signal. Read bar is used to read the data from memory or IO device which resides on the 8086 local bus. This ready signal is used to for 8086 enters into a wait state. The ready signal from memory or IO is synchronized by the 8284, that is a clock generator from the ready signal. The signal is active high, so its signal is 1. So next interrupt request, it is the level of trigger maskable interrupt request. A subroutine is vector via an interrupt vector lookup table located in a system memory. This input is examined by the wait instruction. If the test input is low, execution continues, otherwise the processor waits in the ideal state. Next, NMI is a non-maskable interrupt. It is an edge triggered input which causes a type 2 interrupt. Non-maskable interrupt is not maskable internally by the software. Next, reset button. The signal is used to reset the 8086 processor. It causes the processor to immediately terminate its present activity. The signal must be active high for at least 4 clock cycles. That means one T1. It restarts the execution when the reset returns low. Clock button. The signals provides the basic timing for the processor and bus controller. The clock frequency may be a 5 MHz or 8 MHz up to 10 MHz depending on the version of 8086. And VCC, that means that the 40th pin VCC is a plus 5 volt power supply pin. The opposite to the ground 20th pin, that is the ground. There are in 8086 they are using a 2 ground supply, the 20th pin and the first pin also using as a ground supply, that means 0 voltage power supply. The 33 pin is used to divide the minimum mode and the maximum mode. This pin indicates what mode of the processor to operate in. Memory IO pin. Next, memory IO is used to distinguish a memory access from an IO access. Memory means the voltage is high, that means 1. IO is low, 0. If there comes the 0 signal, that will act as a IO. Next, write button. It indicates the processor is performing a write memory or write IO cycle. It's depending on the state of a memory IO signal. Interrupt acknowledgement. The signal indicates the recognition of an interrupt request. It's used as a read store for interrupt acknowledgement cycles. ALE, that's address latch enable. The signal is used to demultiplex the address and data lines. That means AD0 to AD15, we are having the address and data lines are multiplexed. That will convert into A0 to A15 and D0 to D15. It's a high pulse acting during the T1 of any bus cycle. DEN is a data enable. The signals informs the transceiver that the 8086 is ready to send or receive the data. Hold. This is the DMA controller. Hold an HLD or DMA access. The signal indicates the another master, that means a DMA or processor is requesting the host 8086 to hand over the system bus. Hold acknowledgement, that means HLDA. On receiving hold signal, 8086 outputs. HLDA signal high as an acknowledgement. With the help of S0, S1 and then S2, the machine cycle should be processed. If all the S0, S1, S2 all having the 0, that is interrupt acknowledgement. S2, S1 signals are 0. S0 is 1 means IO read. S2 0, S1 is a high signal, and then S0 is a 0 means IO write operation. S2 is 0, S1 S0 is a high means it's a halt operation. Next, request grant. These pins are used by the other local bus masters to force RQ or GT the processor to release the local bus at the end of the processor current bus cycle. Lock button. This port is used to indicate that other system bus masters are not to gain control of the system bus while lock is activated low. This lock signal is activated by the lock LOCK prefix instruction and remains active until the completion of the next instruction. Next, Q status. We are using two status like Q status. Q is 0 and Q is 1. The Q status is valid during the clock cycle, after which Q operation is performed. If the both Q is 0 and Q is not low signal means there is no operation. If Q is not is high, Q is 1 is low means first byte of the opcode from Q. The second Q is 1 has a high operation. Q is not is a low means empty the Q. Both are having a high voltage, that means a high signal means subsequent byte from Q. And then power supply opposite ground supply, there are 40 pins are included. It will we can divide the minimum mode and maximum mode of operation by using the 33 pin. When M1 Mx bar is equal to 0 means it's a maximum mode of operation. Equal to 1 means it's a minimum mode of operation. Pins 24 to 31 have a different functions for minimum mode and maximum mode. For minimum mode of operation, it's a connected M1 Mx bar is connected to VCC, that means a plus 5 volts. All control signals for controlling a memory and IO devices are generated inside the 8086 microprocessor. In this mode, peripheral devices can be used with the microprocessor without any special consideration. Next, a maximum mode. In a maximum mode 8086 based system, an external bus controller, that means we are using an Intel 8288, that is the external bus controller used to 8086 processor. It has to be employed to generate the bus control signals. We are in the maximum mode operation, the important signals are MRDC, MWTC, IORC, that means memory read command, memory write command, IO read command, IO write command, and then advanced memory write command, advanced IO write command. 3 numbers of 8-bit latches, that means the Intel 8282 are latches used in this 8086 processor are employed to demultiplex the address lines. The latches are enabled by using the address latch enable signal generated by the bus controller. 2 numbers of octal bus transceivers, that means Intel 8286 we are using as a transceiver, are used as a data transceivers. The signals data enable and data transmitter receiver are generated by the bus controller are used as a enable and direction control respectively. In the clock generator, that means the 8284 Intel is used for generate the clock, reset and ready signals for 8086. The quartz crystal frequency of 15 MHz is used to connect to the 8284. This is the overall explanation of 8086 pin diagram. Thank you.